Good morning, guys. Good morning. Yeah, for good afternoon, it's still 8 minutes are there. Good morning, good morning. Good morning, guys. So, I welcome you to NEET World Institute. So, in today's session, at this session, we are going to deal with 100 days challenge of physics. So, in the previous session, we have discussed about the PYQs of NEET. Okay, PYQs of NEET. So, in this session we are going to see particularly about the 100 days challenge, like the top important topics in 100 days. Okay. So, before that I going to introduce the one thing, like our NEET World Institute is intaking the admission for the second batch for the NEET as well as the JEE mains. Okay. And for this the fee structure is like just 333 per month. For 11th, 12th are the power step to medicine as well as the power step to the engineering also. Okay, just 333 per month. So let us go into the topic. So yesterday we have completed the topic that gravitational potential and field, right? So in today's topic now we are going to start with variation, like weight variation with height as well as the depth. Okay. The first we will complete what are the formulas are taken place or we need to cover in this topics, and let us discuss the question whatever asked in NEET PYQs as well as JEE PYQs. Okay. So weight and gravity basics. Like weight, we know that it is nothing but force due to gravity, right? So mass into G, like mg is the formula for the weight. Okay. So where m is the mass of the object and g is the acceleration due to gravity. So g is not constant, it varies with height as well as the depth, which is from the earth's surface. Okay. For the earth's surface, if we see, g is nothing but 9.8 meter per second square, or else for the problems we will use, it is approximately 10 meter per second square. But when it varies with height or depth, g changes. That's what we are going to discuss in this session particularly. So variation of g with height, first thing. So let us consider the radius of the earth is r. We know the radius of earth is nothing but 6400 kilometer, right? 6400 kilometer. Yeah, I will write it here, the radius of the earth. So which is r is equals to 6400 kilometer, which is nothing but 6400 kilometer, right? So h is the height above the earth's surface, we will consider. So depth in the sense like the height below the earth's surface we will say. So here h is nothing but height above the earth's surface. For that the formula is like if the gravity changes like with respect to height, so the new gravity will be equals to g into the original gravity, okay, into 1 minus 2h by r, 1 minus 2h by r, okay. And for weight, like the thing is when h is much smaller than r, it is very smaller than the r, okay. Now the weight is nothing but the change in weight, guys, like original weight we know that W, the change in weight with respect to height, that is WH we have taken, okay. WH is like WH by W, which is equals to 1 minus 2h by r, okay. The same thing, whatever the formula we have seen for the gravity, like new gravity, right. So GH is the new gravity when height changes should be equals to the original gravity. G is nothing but 9.8 meter per second square now. So we will take as it is and into 1 minus 2h by r, 1 minus 2h by r. When I need to use this formula, when h is much smaller than the radius r, the radius of the earth, okay. Now weight decreases with increase in height. The thing is weight decreases with increase in height. So the first formula we have learned, like gravity when it changes to height h. Second one, the weight when height changes to h. And the third point is weight decreases with increase in height. So W decreases with increase in height. Height increases, weight decreases. So valid for small height, example tower or lower orbit satellites. Okay, and exact formula for larger height. When I compare the radius of the earth, is there? No. When height I will take larger, no. That time I need to use the formula. GH, the new gravity, is equals to the original gravity is there, no, G, that is 9.8 meter per second square, into R by R plus H the whole square. So previously we have seen that H is very smaller than R. In that case, G into 1 minus 2H by R. Yeah, this 1 by 2H by R. But in this case, no, like it is G into R by R plus H the whole square. So two formulas are there, G into 1 minus 2H by R and G into R by R plus H the whole square. Two formulas. Okay, keep in mind there are two formulas when H is much smaller than R and H is almost like greater than R will consider. Okay, that is G into R plus H by R, R by R plus H the whole square. Okay, you can take a note of this. Antim Verma, hi. Hello. Yeah, can we go for the next one? The depth. Height we have completed, no. Next we'll go for the depth, guys. Okay. Two formulas, and the thing is weight decreases with increase in height. Okay. Remember the 3 points here, 3 key points. Okay. The next thing is variation of G with depth. Variation of G with depth. Now, in the previous case we have seen height H. Now it is above the earth surface. Now the below the earth surface, that is depth, below the earth surface. Now the formula will be, there it is 2H by R, but here new gravity for the depth should be equals to G into 1 minus D by R. That's it. 2H by R, here D by R. 2H by R, D by R. So for weight also the same thing. The new weight of depth is equals to W into 1 minus D by R. That's it. Yes or no? Now the key points are, weight decreases linearly with increase in depth. There weight decreases with increase in height. Here also weight decreases linearly with increase in depth. Okay, first point, second point and the third point. Okay, the fourth point is, at Earth's center G is equals to 0 and weight also will be 0. If G is 0, no, obviously weight will be 0. So fourth point is G 0, weight 0 at Earth's center. Okay, so totally we have learned 4 points here, there 3 points we have learned. Okay, take a note of this. We'll go into the next point. We'll go for the next point, guys. Completed? Yeah. You can take a screenshot of also. Or yeah. The thing is, I'll expand this so that you can able to see. Yeah. So the situation and the gravity and the weight. So when the situation on the Earth's surface, gravity is maximum, weight also maximum. At height, decreases as 1 minus 2H by R. That's the formula we have seen now. G into 1 minus 2H by R. And weight obviously decreases. For at depth, 1 minus D by R. G into 1 minus D by R. G into 1 minus 2H by R. So weight also decreases. At Earth's center, G is equals to 0. Weight also will be equals to 0. These are the points we have seen in the last 2 slides. That is for the variation of g with height, variation of g with depth. Yeah, so stay tuned guys, we'll go for the questions. Okay, we'll solve the questions, as many questions as possible we'll solve. So percentage decrease in weight at height 2h by r into 100, and for the depth it is d by r into 100. There we have seen the formula. No, that same formula only, 1 minus 2h by r, 1 minus d by r. So the percentage decrease they are asking means into 100, 2h by r into 100, it is d by r into 100. Okay, keep in mind. Okay, once again we'll see the formula and we'll go for the questions now. So first one we have seen, like the what is the weight, it is nothing but m into g. The next thing is variation of g with height, formula is g into 1 minus 2h by r when h is less than, like much less than r, and for the weight also it is 1 minus 2h by r when like it is larger height, it is g into r square by r plus hd whole square. I mean r by r plus hd whole square also you can take, or else r square by r plus hd square. Okay, both are correct only. And for the weight, like g with depth, so g into 1 minus d by r, for weight also 1 minus d by r. Okay, and at the center g is equal to 0, w is equal to 0. Yeah, we'll go for the questions now. The first question guys, the first question of the session, if the value of g at the surface of the earth is 9.8 meter per second square, what will be its value at depth of 1600 kilometer, that is 1600 kilometer from the surface. From the surface. Okay, what is the question they have asked? They have asked the depth, and what they are asking, the value of g. Okay, where is the pen? Yeah, I'll take the pen now. I'll write the given terms first of all. What are the given terms here? So initially g is 9.8 meter per second square, and the depth is given as d is equals to 1600 kilometer, and we know that the radius of earth is 6400 kilometer, right? I need to find what is the value of new g, that is, what is the formula? G, d should be equals to g into 1 minus d by r. For the depth, for the height it is 2h by r. Okay, no need to confuse here. So what is the thing? 9.8, no, g is nothing but 9.8, 1 minus, what is d here? 1600 kilometer. So 1600 by 6400. So that's it, you will get the answer. When we calculate this equation, we will get the answer of the variation of g with depth d. So what will be the answer here? 9.8 into, so 2 zeros and 2 zeros will get cancelled out, 64 minus 16 by 64. Okay. Now, so for yeah, directly you can do it. You can consider 10 also, but you will get approximate answer. That's it. You will get the approximate answer. What is the answer? 9.8, no, 9.8 into 64 minus 16. Yeah, it is. What is the answer? 64, 58, 48, 48 by 64. This is 24 and this is 32, again 16, 12, 3 sir, and this is 4 sir. Am I correct? No. Now the final answer will be 9.8 into 3 divided by 4 twice, and this is 49, 4.9. So 50 into 3 is 150, so minus 3 it is nothing but 147 divided by 2. So 147 point, no, 14.7 divided by 2. So 7.4 meter per second square, right? Obviously, like equal, approximately 14.7, no. So if I multiply 7.4 into 2, I will get 14.8. So approximately I will get the answer as option C. Option C. Understood na? We'll go for the next question. The next question, yes, at what depth below the earth's surface is the value of G reduced by 36%? So they have said G is reduced by 36%. What is the remaining percentage there? 64, right? 64%. So can you give the answer for this question? I'll give 30 seconds of the time here. You can give that like easy now. I'll give the formula also. I'll give the formula. From that you need to write the variation of G with depth is 36% has been reduced. So remaining is 64%. So the formula is variation of G with depth D is equals to G into 1 minus D by R. I need to find D in terms of R. Need to find D in terms of R. Completed? Okay, we'll check the answers now. So G, like the variation of G is reduced by 36% of the original G, right? So remaining will be 64%, no, 64 by 100 G, which is nothing but 0.64 G. Now take the value of GD here, okay, in this equation. So 0.64 G is equals to G into 1 minus D by R, where GG will get cancelled out. So 0.64 is equals to 1 minus D by R. Okay. Now D by R should be equals to 1 minus 0.64, which is equals to D into this. D is equals to 0.36 R. 0.36 R. Yeah. So 1/3 of 100 is 33.33 something. No. Yeah. So approximately equals to R by 3. Approximately equals to R by 3. I can write this 36 by 100. So which is approximately equals to 1/3. I can say no, like the 0.33% I can say no. Yeah. Easy no? Only the formula you need to learn, and the understanding of question is important. So if you understand the question as well as if you know the formula, you will get the answer easily. Okay? Can we go for the next question? The third question, the value of acceleration due to gravity decreases with. Give the answer for this question, we'll see. Yes. So it is option, which option? As increase in depth, option B, right? As depth increases, gravity decreases. Here decrease in height they have mentioned, but what we have seen, when height increases or depth increases, obviously it decreases. So increase in radius of earth, no. How? It's constant, right? Radius of earth is constant. Will it increase? No. Decrease in depth, no, obviously. When depth increases only, the value decreases. Okay, option B is there, but they have mentioned height also. But if they mentioned height also increases, both option A and B will come. But the option B is the correct answer. When depth increases, G decreases, as well as height increases, G decreases. Okay. I will write that also. You can note that. Okay. I will write the thing also here. You can note it down. When depth increases, gravity decreases. Gravity decreases. Okay. As well as for the height also. as well as for the height also. Height increases, gravity decreases. Height increases, gravity decreases. Okay. That's why I have told, remember the points whatever I said in the slides, so that you can easily able to answer the PYQs. So whatever I am bringing now the questions, everything are PYQs only. Okay, everything are PYQs. So whoever watching in online now, you can give answer in the comment box. We'll check it. Okay, whether it's right or wrong. Yeah, still many questions are there, like 1, 2, 3, 4, 5 questions are remaining. We'll see everything. Okay. Now the question, the given question is the weight of an object at height r/2 above the earth's surface is W. Okay. What is its weight on the surface of the earth? Okay. So above the surface, that is with height increases, the r/2, like height increased by r/2, surface weight is the weight is W. What is the surface weight they are asking? I will write it that. Yeah. So the formula is variation of weight with depth is equals to W into 1 minus d by r. Right? Yes, it is height. No, height r/2. What is the formula I should use now? What is the formula I should use? Yes, it is r by r plus hd whole square. So W into r by r plus hd whole square. So for the depth we will use that formula. For height 1 minus 2h by r, but height is like it is r/2 we have considered. R/2 in the sense 3200 kilometer. Radius of the earth is 6400 kilometer, right? Now from this I need to find W. I need to find the W. Give the answer. Yeah, you can give the answer in the comment boxes, whoever watching. Okay. Whoever watching, you can give answer in the comment box. We'll check it. Okay. So let me solve now. So variation of this height now. Yeah. This is height. So variation of weight with height is nothing but W has been given. Okay. Let me consider this is W naught original, which is equals to W naught into r by r plus, what is the height? R/2, right? R/2 the whole square. So W naught into, so what should be the answer here? So when I take the LCM, 3r/2 will come. So when I take the 2 upside, 2r/3r the whole square. R will get cancelled out. So W naught is nothing but 4/9. From this I need to find what is W naught, the original weight. That's the answer of this question. That's the answer of this question. Okay. You can give answer of this question, guys. We'll go for the next question. You can give answer in the comment box. We'll check it. Okay. Yes. We'll go for the next one. That is a weight of a body at a height h above the surface of earth is 36 Newton. If height is equal to the radius of the earth, what is the weight on the surface they are asking? So they have mentioned that height is equal to the radius of the earth, which means h is equals to r. H is equals to R, the first point, and the second point is WH is equals to 36 Newton. I need to find what is the original weight in the earth's surface. So what is the formula? WH is equals to W naught into R by R plus H the whole square, R by R plus H the whole square. Okay. So from this is 36 Newton should be equals to the original weight into R by R plus, what is the height? Equal to radius of the earth, which is R the whole square. So which will be 36 is equals to original weight into R by 2R the whole square, where RR will get cancelled out and the remaining thing will be W naught into 1 by 4, where W naught, like original weight of the, like weight at the surface, earth's surface, should be equal to 36 into 4. So 36 2s are 72, 72 2s are 144, right? 144 Newton. What is the answer? Option A is the answer. 144 Newton. Yeah, we will continue with the next question. The next question is, at what height above the earth's surface is the value of G reduced by G by 4? So originally G was there, like G equals to 9.8 meter per second square. Now it has been reduced to G by 4. So the formula is, where is the question? Yeah, the question is this one. Above the earth's surface. Okay. The pen came, no? Yes. Now formula, G, variation of G with height H is equals to the original G naught into R by R plus H the whole square. Okay. Now GH they have said is G by 4 reduced to G by 4. Now what will be the height they are asking? No, height, what is the height? What is the height? So G by 4 is equals to G into R by R plus H the whole square, where G and G will get cancelled out. If I take this square this side, it will become root over 1 by 4, which is equals to R by R plus H. So 1 by 2 is equals to R by R plus H, where R plus H will be equals to 2R, H will be equals to 2R minus R. So H will be the radius, equals to the radius, H is equals to R. Option A is the correct answer. Option A is the correct answer. Can we go for the next question? Yes. The acceleration due to gravity at depth is 2 by 3 g. What is the value of d? What is the value of d? Depth formula, it is 1 minus d by r. No, 1 minus d by r. We take a pen. Let me take this pen now. Yeah, where it is? Yeah, it came. So g with d, like variation of g with d, should be equals to g into 1 minus d by r. What they have said, variation of g with d is nothing but 2g by 3. 2g by 3 should be equals to g into 1 minus d by r. So I need to find value of d in terms of r I need to find. So g and g will get cancelled out. So 2 by 3 is equals to 1 minus d by r, where d by r is equals to 1 minus 2 by 3. 1 minus 2 by 3. So what will be the answer? 3 minus 2 by 3 is nothing but 1 by 3. So d will be equals to r by 3. This is the answer, guys. This is the answer. D is equals to r by 3. So the last question in this session we are going to see now. If the value of acceleration due to gravity becomes 9 by say 6 by g by 9 at a certain height, what is that height? Okay, what is that height? They have not mentioned the height. No, I need to find the height, value of height here. The value of height. So the gravity becomes 9 by g. Sorry, g by 9. No, g by 9. So the formula is g into height. No, this is variation of gravity with respect to height is nothing but g into r by r plus h the whole square. R by r plus h the whole square, where gh is nothing but g by 9. So g by 9 should be equals to g into r by r plus h the whole square. So g and g will get cancelled. If I take this square this side, it will become under root of 1 by 9. So 1 by 3 I'll get is equals to r by r plus h. R by r plus h, where r plus h is equals to 3r, h is equals to 3r minus r is 2r. This is the answer. So this is the height when the variation of g becomes g by 9. 2r is the answer. Okay guys, so we have completed the topic variation of g and w with respect to height and depth, and we have seen the PYQs also. So stay tuned for the upcoming session of NEET PYQs as well as the 100 days challenge topic, which is going to take place exactly 10:50 AM and 11:50 AM. Okay, regularly. Okay guys, until we'll meet tomorrow. Bye bye. Bye bye.